Hey everyone, it's Matt here with Nightrun Studio, and we're making a Metroidvania. In our last video, we got our player moving around and flipping from side to side, and this time around, we're gonna add some jumping. But not just jumping. We'll start with the basic jump, add some ground checking so we can't fly, then we'll also add variable jump height, making it so that we can hold the button to jump higher, and also some variable gravity, so that we can add things like a float at the apex and quicker falling speeds. That's where we're headed in this video. Let's get started. First things first, let's head to our assets folder and go to our input systems actions. Here we already have jump predefined with the spacebar on the keyboard or the south button in a gamepad. You can change those if you like. Now let's go over to our properties. You'll notice that jump is set to be a button, and we're just gonna add some interaction here. If we expand this, we can choose press, and we don't just want it to fire when we press, we also wanna get a fire when we release. That'll allow us to hold the button in order to jump higher, and then cut our jump when we release. All right, next let's head into our player script. Now at the moment we are putting all of our movement into this one script, which will get bloated eventually. That said, as we start, we're just gonna put everything here and then we'll refactor as we go to make this clearer and more modular. The first thing we're gonna wanna do is define our jump force. Though before we do that, let's just go here above our speed and add a header for movement variables. We can also add a public float here for our jump force. Next, we need to actually take in some inputs from the player. So let's head down below our onMove method and create a public void onJump, which will also take in an input value called value. Since this method does get called whenever we press the button, we can just go ahead and program our jump in here. We'll just set our rigid body's linear velocity to be equal to a new vector 2, similar to what we did with our movement, except that here we want to allow our rigid body to do its own thing with the x. We'll just do rb.linearvelocity.x. Then for our y, we're just going to input the jump force. We can go ahead and test this right away. Just make sure to give the player some jump force. I'm going to start with 10, which feels pretty floaty. So in my rigid body, I can adjust my gravity scale to something like 4, and it starts to feel better, but now it's cutting out my jump force. It's also, I've got the ability to multi-jump. We'll fix that. So go ahead and play around right now. I'm gonna stick with about a jump force of 20 and a gravity scale of 6, but all of these will be modified later, so don't spend too much time on it just now. Our first improvement is gonna be to get rid of that infinite multi-jump by adding a ground check. The way we're gonna do this is by making an invisible circle at the player's feet that just checks for any objects that belong to a ground layer. So let's make a ground layer. If we click on our ground here, you'll notice it's currently set to default as its layer. We can click on that box, and we need to add a new layer here as there isn't one yet for ground. Here we can just pick any box we want, type in ground. We'll then need to select our ground one more time and make sure we apply that layer. Now next, we need a way for our player to check for ground. So we're just gonna open up our player's game object here, and along with our sprite, we're gonna add a new empty game object, which we'll call ground check. We can move this down by his feet, and this is just where our circle will originate that looks for ground. All right, let's head into our code. Now our ground check is going to need a number of different variables, so let's create a header here called ground check to keep things organized. We'll start with a reference to that ground check we just made in Unity. This is a public transform called ground check. We'll then add a public float, which will be the radius of the circle. Let's call this ground check radius. We'll add a public layer mask called ground layer, which just lets our player know which layers count as ground. Finally, we're going to create a public bool called isGrounded, which is just how our script will track whether or not the player is currently on the ground. Now we're going to want to check constantly to see if our player is on the ground, so we can go to our update method and add check grounded in here. That said, we've not yet created that method, so let's go ahead and do that right above our flip. So this is going to be a void method called check grounded, and here we'll just have one line for now, which is just going to take our isGrounded bool and check to see if. And here we're gonna use the physics 2D library from Unity, which just allows us to do some cool things like create an invisible overlap circle. Now in brackets here, we can define what that circle is. So first of all, we want it to originate from our ground check dot position. Its size is gonna be equal to our ground check radius. And finally, what is it looking for? Well, it's looking for objects in the ground layer. And since we're calling this all the time, we'll constantly have that value updated. Now we can head down to our onJump method, and we're just going to use that bool to gate whether or not we're allowed to jump. So if, and here we'll do value, and we're going to put dot is pressed. Now if that's true and is grounded is also true, then we want to allow our player to run its jump logic. Now we could test this already, but first I'm just going to add a helper method here that's going to allow us to get our ground check just right. we're gonna add a private void on drawGizmo selected method. And this is just gonna be something you use to picture that circle that's checking for ground. So first of all, we'll just tell it that the gizmo's color for this object will be red. You can pick any color you like. Finally, we're gonna make it so that the gizmo we draw is a draw wire sphere. So this is gonna sort of mimic our overlap circle we created above. This will originate at our ground check position, and it will be the size of our ground check radius. All right, if we pop back into Unity now, we can just click on our player and we've got some work to do. Let's drag our ground check transform in there, and let's also make sure that we actually have a radius set. So right now, if I click on that and give it, say, like a 0.5, we'll get a nice generous radius. Finally, I'm just going to pick a ground layer. For now, we're just gonna add the ground layer in there. But later on, we can add more if we want the player to be able to jump off the heads of enemies or buildings, that sort of thing. All right, when we test that out, we can see that things are working nicely and the multi-jump is now gone. That said, our jump still feels a little bit wooden. We're gonna add 2 more updates to this. The first one is just gonna be that we're gonna add variable jump height, so that if we hold the button, we jump higher, and if we let go early, we cut the jump. Now the good news is this step is really easy to do. We're just gonna make a public float here called jump cut multiplier. This will be how much we want to cut the jump by when we release the button, and I'm gonna do it by 50%, so we'll do 0.5. Then down in our onJump method, we're just gonna add an else statement, which will account for the situation where the button's been released. We might add multiple things here, so I'm gonna just put my if on the next line. And if our rigid body's linear velocity.y is greater than 0, meaning we are currently on our way up, then we can just copy our jump line from above, leaving our x at the whim of whatever direction we're pressing. However, for our y, instead of jump force, we're just gonna take our rigid body's linear velocity.y and multiply it by our jump cut multiplier. So instead of just normal gravity, we're gonna actually cut it in half. So we get a nice smooth deceleration, but still a pretty quick one. All right, now when we get in Unity, things are working quite nicely. We can tap the button lightly to do a little jump or hold it to jump higher, and you can play around with that jump cut multiplier if you like to see what number suits you best. All right, next up, we just want to change our gravity so that we kind of come down a little less floatily. This one is going to take just a little more work, so let's head into our movement variables here and define our gravity. We're going to have a public float for our normal gravity, as well as another for falling gravity, so when we're on our way down, and finally a public float for our jump gravity when we're on our way up. I'm just gonna add in a start method here, as soon as the game starts, we wanna make sure that our rigid body's gravity scale is set to whatever our normal gravity is. Next, in our update, we wanna make sure that we are constantly applying our variable gravity. So we'll call that method, and then we just need to create it. So let's come down above our check grounded and add a void apply variable gravity method. Now we just need to account for all the possibilities. So if our rigid body's linear velocity y is less than 0, meaning we're falling, we want our rigid body's gravity scale to equal our fall gravity. Now else if the rigid body's linear velocity y is greater than 0, then our gravity scale is going to be equal to our jump gravity. Then if we are neither rising nor falling, we just want our gravity scale to be its normal gravity. Now we do want to be careful here because currently just the slightest little bit of rising or falling could trigger a change in gravity, which could make the game stutter a little. So let's just add a protection here of a threshold. So we'll only do our fall gravity if our velocity is like -0.1, and then same for rising, it has to be greater than 0.1. Let's make our normal gravity 6, and for fall gravity, I'm gonna start with 9, a 4 for jump gravity. All right, when I get in the game, that's actually already starting to feel pretty good. I feel like I have a lot more control over what he's doing. That said, I'm just gonna add a little more power here. Let's maybe make our fall gravity more like a 12. Already that's starting to feel even better as I descend a little quicker, making things just feel a little more snappy. You can play with the numbers to get them just how you like them. Now, as I mentioned earlier, we'll be doing a number of refactorings throughout this series to keep our code modular and readable. That said, there's just a few things I'm not liking about this script right now, and I want to leave you with a nice clean code. First of all, in update, you'll notice that we are applying our variable gravity and also checking for groundedness in update. Those are physics-related functions, and we want to make sure they're done smoothly, so let's put them in fixed update. Next up, we're doing some inconsistent logic here, where we're taking our inputs down below, but then for movement, we're applying it in fixed update while we're applying our jump within the place we're taking in the input. This just keeps things inconsistent and can make it less readable as our script grows. So let's fix that. We're gonna go with more of a state-based structure here, where we create separate methods for our movement and jumping. So let's make a private void handle movement method here, and we can just cut out our movement logic from fixed update and put it in there. Then in fixed update, we're just gonna make sure that we constantly call handle movement. This doesn't change anything in how it works, it just means now that if we have a problem with our movement, we know to look in the handle movement method in order to fix it, and later on we can add more logic to make our movement feel better. Now let's do the same for our jumping. So we'll make a private void method here called handle jump. Now in order to call this method, we need a way to track when a button's being pressed, as right now only our onJump method knows that. So here we're just going to come up top, and along with our move input, we're just going to put a little comment that this is a place where we track our inputs, and we're going to make two private bools, so true-false statements. The first is going to be jump pressed, which will track the status of whether we've pressed the button, and also a jump released bool. Now that we have those, we can do our logic for handle jumping. So if jump is pressed and is grounded as true, we can then go down to onJump and grab our jump logic line and put that in here. And as soon as we jump, we also want to make sure that our jump pressed variable gets set to false so that we don't have it firing multiple times. Next, if jump is released, we can head down to jump and grab the jump cut logic. Here we'll make it so that if jump is released and our linear velocity y is greater than 0, meaning we're going up, then we're going to add our jump cut multiplier. At this point, we just need to make sure that we're actually calling handle jump at some point. So we'll come up to our fixed update and call handle jump right after we call handle movement. Now we can just make sure that our onJump methods are only handling those two variables, jump pressed and jump released. So it no longer needs to worry about is grounded. However, if the value is pressed, then we want to make sure jump pressed gets set to be true. We'll also at this point make sure that jump released is set to false, as it can no longer be true if we're pressing the button. Then down below here, since we're not pressing the button, we know jump released is true. Now for setting jump released false, we're actually just going to head up into our handle jump method. We just want to make sure here that right after making a jump, we set jump released to false. And also, when we let go of the button, that's also a place we're going to want to make our jump released false. Now I know that was a lot of extra work to not actually change anything functionally. However, our code is much better organized now. We've got all of our variables up top, our two update methods appropriately calling the right things, and now our state-based approach where handle movement and handle jumping are all in their own self-contained methods. Then down below, we've got our helper methods that allow us to do things like applying gravity and checking for ground. We've got our input checks as well as our gizmos. Now we'll just go into the game to make sure we didn't break anything, and yeah, it looks like it's still working just as before. We do have the variable gravities, and just to demonstrate really how different they are, I'm going to change my fall gravity to 16 and my jump gravity to 2, so you can see a really slow rise with a floaty apex and then a really quick descent. So now you can play around with those and get them just the way you want them. All right, I hope you found this one helpful. In the next video, we're gonna get this guy animated because he looks pretty stiff here. Hope to see you in that video. Until then, this is Matt with Nightrun Studio. Cheers.